Good morning / afternoon, Algebra 2 students. It's Miss Heart here for your pre-assessment functions go-over. This one was not so good. So if you remember, we did this on Wednesday, a virtual Wednesday. 85% of you actually completed it, and the grades were horrible. 24% average, not so good. So I don't know if that was because there was a lot of inputs on this one, so I don't know if it was technical issues or it was understanding, but let's go over the questions. So let's first remind ourselves what a function is. Remember, a function relates an input to one output. You put something in, you get something out. You don't get two things out, you just get one thing out, okay? Input, output, function notation looks like this, domain and range, you could have seen it like this. And then we use the vertical line test to prove whether something was a function. Every x only has one y. Okay, function notation, it looks like this. We have ourselves the name of the function. This letter might be F, it might be any letter of the alphabet, but that tells you the name of the function. What's in that parenthesis is the variable that's used. So you can use X or you can use A. No matter what, the variable used here will go into your rule. Okay, usually we have an expression over here which represents your function. So f of x is the same thing as y. F of x is your output, it's your y value, and then over here is what your equation is, the rule of your function. Independent and dependent variables, okay? So a dependent variable depends on an independent variable. So usually our x is the independent and our y is our dependent because it depends on what x is, will tell us what the y is. So like some examples like of dependent versus independent, the amount of your check depends on how many hours you work. Your grade in Algebra 2 depends on the effort you give in class. So that's like a little description of independent versus dependent, okay? First question, evaluating a function level 1. Given g of x equals negative x minus 2, find g of negative 5. So whatever is in that parenthesis, that's what you're plugging in for your variable. So if it's g of negative 5, the notation looks like this. So you plug the variable in. Okay, remember, x is being replaced by negative 5, but you still have that negative out front because it's a negative x. So then cleaning it up and doing the arithmetic, the double negative there is going to make 5 minus 2. So g of negative 5 equals 3. It equals 3. All right, ladies and gentlemen, your turn. Oh, pause the video. All right, hopefully you pause the video. If not, pause the video, try this problem. So when you plug in negative 6, you end up getting 12 plus 5, so h of negative 6 is positive 17. I don't know why that was so low. Makes me nervous. All right, level 2, taking it up a notch. We had a 30% get this right. So I think that this became, because the negative in front of your variable always throws students off. So we have negative x squared minus 12. So when you go to plug it in, you still have that negative. Your x is negative 3 squared and then minus 12. Remember, good old PEMDAS, you got to do exponents first. So you're going to evaluate what negative 3 squared is. That's going to be positive 9, and then you drop that other negative. So be careful with that. So negative 9 minus 12 will give you f of negative 3 equals negative 21. So just be careful with those negative out in front of your variables. Technically, they count. No, I don't want to say that. I was going to say they count twice, but that's not necessarily it. All right. Your turn. Pause the video. All right, here we go. When you plug in negative 4, it looks like that. Okay, how do I do this? Oh, I do it all in one step. So negative 4 squared is 16. 16 times 2 is 32. Negative 10, negative 4 make a positive 40, and then you drop down that positive 13. Add those up, you get f of negative 4 equals 85. Did you get it right? If not, where'd you get it wrong? All right, 3, evaluating a function according to a graph. So y equals f of x, that's this guy. Boom. Those of you that know, that's an absolute value equation. But anyway, we won't go there. So if they want you to evaluate f of 3, That X value is 3. Your X value is 3, so they want the Y coordinate. So go to your graph where the X value is 3, so that'd be right there. Go to your graph and see where the point is, so that would be right there. And then what's the Y value? The Y value of that coordinate point is 7. So f of 3 equals 7. F of 3 equals 7. Okay, you're finding the coordinate on your graph. All right, your turn. Pause the video. All right, f of 5. So where is x is 5? That's going to be right where the coordinate point meets that graph is right there. So if my x is 5, my y value is -2, meaning that f of 5 is -2. -2. F of 5 equals -2. Okay, did you get it right? If not, we'll learn what you did wrong. All right, here we go. So this went down to 7%. There was a lot of stuff in here, and if you left some out, you know, that's probably why this one went so bad. So anyway, these have to do with like learning about what the function actually means. It actually stands for something. In this form, in this situation, we have in a board game a certain number of points is awarded to a player upon rolling a 6-sided die labeled 1 to 6. According to the function f of x equals 4x plus 3, where x is the value rolled on the die. Find and interpret the given function values and determine an appropriate domain for the function. Now remember, domain is your x values. Domain are all the x's, all the inputs that you can put in. So for the first part, it says f of 2. So they want you to plug in x equals 2. When you do that, you get 4 times 2 is 8. 8 plus 3 is 11. Okay, so now you have to kind of get into what that means. So remember that in the problem, it tells you that x is the value rolled on the die. So meaning when a 2 is rolled on the die, the player is awarded 11 points. Okay, now the next question, it says this interpretation blank in the context of the problem. You pull it down and it either says it makes sense or it doesn't make sense. You can roll a 2, so this definitely makes sense. 5.5. That's a little funny, but let's do it. 5.5, plug it in. 4 times 5.5 plus 3, you're going to get 25. Okay, meaning when a 5.5 is rolled, the player is awarded 25 points. However, have you ever had a dice be 5.5? Have you ever rolled something and you get a 5.5 out? Me neither. If you say you have, I don't think you have. This interpretation does not make sense. There's no 5.5 on a 6 rolled die. Okay, so that's what that one means. All right, this was like a 4-part question. So yet again, we have the same situation. We have one more to do, f of 7. So if you roll a 7, you do 4 times 7 plus 3, you would get 31 points, meaning when a 7 was rolled, you would get 31 points. But again, if a die is labeled 1 through 6, are you going to roll a 7? No, so it doesn't make sense. All right, so then the next question. Based on the observation above, it's clear that the appropriate domain for the function is. So then you have all these choices: non-negative real numbers, A through B, integers, whole numbers, positive numbers, integers, and A through B. So now we have to remember what all these things mean. Okay, you might not remember what real numbers are. Here's a beautiful looking chart. Okay, we have different classifications of numbers. Okay, the big realm of classification is your real numbers. Anything that can be written as a number is considered a real number. This is the whole kit and caboodle. Then we get a little smaller with rational numbers. Rationals are anything that can be written in A over B, anything that can be written in fraction form. So you've got whole numbers, you got decimal numbers and that. Irrational numbers are up in this little corner. They're very tiny. They're numbers that go on forever and don't form a pattern. So, you know, you got your square root, you got your good old famous one, which is pi. Integers are any positive and negative whole numbers. Whole numbers are from 0, 1, 2, 3, on and on and on. And natural numbers are only from 1, 2, 3, 4, 5, 6. So those are kind of our definitions. So let's go back to the problem at hand. What x's could we put into this? I could only put in a 1, a 2, a 3, a 4, a 5, and a 6. So real numbers, A through B, we wouldn't be putting any decimal numbers, so that's not it. Non-negative real numbers, but that still means I could do like positive 1.5. That doesn't work. Integers are any positive or negative numbers. I can't roll a 0, so whole numbers is out. Positive integers, that would work, but not when it goes dot, 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 like there's no 7 or 8 or 9. Integers from A to B. There's your winner right there. Integers A through B, because you can only roll from 1 to 6. And only integers, so that means all your whole numbers. So 1, 2, 3, 4, 5, 6. So that's the winner on that one. Okay? All right, so pause the video. Here's your chance. All right, ladies and gentlemen, here we go. So they give you an equation. We're talking about doses in medications. So X is the hours modeled by the function. Find the interpret given function values and determine appropriate interval for the function. So round your answers to nearest hundredth. Remember, tens hundredths is the second decimal place. So if you plug in a -3 to this beautiful equation, out's going to pop this answer rounded to the nearest hundredth. Okay? So what does that mean? According to the function notation, remember, X represents the hours, after the medication is given. So this means that -3, I couldn't fit it in there, I don't think. So -3 hours after taking the dose, there are that amount of milligrams of medicine remaining in the bloodstream. However, what is a -3 in time frame? You're not going to take the medicine before you take the medicine. So this one does not make sense. Okay? -3 does not exist in time frame. 18. So if I plugged in 18 to the equation, you would get 4.97, meaning that 18 hours after taking the dose, there'll be 14.97 milligrams of medicine remaining in the person's bloodstream. This makes sense, okay? There's not going to be a lot left because it's been 18 hours since, so it does make sense. Next part, I'm going to pause the video and try this one. Pause the video and try this one. All right, here we go. 3.5, you plug that into it, you're going to get 44.25, meaning that 3.5 hours after taking a dose, there are 44.24 milligrams of medicine remaining in the person's bloodstream. This makes sense. You can take it 3.5 hours. Like this is 3.5 hours. That's what that means. So it does make sense. Okay. Based on the observation above, it is clear that the domain, so non-negative real numbers, any real number between A and B, okay? Integers, whole numbers, what would be the best situation? So you could get any non-negative real number, okay? You could have a weird amount of time that this would work for. Non-negative real number, that would work, okay? Whoa, number 5, write and interpret function notation. All right, so this is where the independent versus dependent variables come in. So Kevin is buying bagels for a family gathering. Each bagel costs $1.75. Answer the questions below regarding the relationship between the total cost and the number of bagels purchased. The independent variable, X, represents, so we have total cost of bagels or the number of bagels purchased. In this situation, the number of bagels is going to be the independent variable. Why? Because then with that will tell you how much the bagel will cost, and the dependent variable is the total cost of the bagel. You wouldn't be able to figure out the total cost of the bagel unless you knew how many bagels you have. So that's why the cost of bagels is dependent on the number of bagels that you buy. Because, and again, this is just another statement, because the cost of bagels depends on the number of bagels. A function relating these variables is b of x. So if you wanted to figure out how many bagels you have, you would take the price tag and then multiply it by x. So just that would go in there. So an equation for your function. So b of 10, so if you plugged in 10, you would be working with 1750, meaning 10 bagels bagels will cost, so you have dollars is the price, so bagels will cost $17.50. Okay, so you just kind of have to make sense of that situation. Think about which variable is dependent on the other. Okay, your turn. So above is, pause me. Unpause. You might not have been able to do this without the stuff on the bottom, so let's just go through it. So we have hunters join the frequent coffee buyer program with Local Cafe. The program costs $10 per month, which allows him to get a discounted coffee price of $3 per cup. Answer the questions below regarding the relationship between the number of cups of purchase and total monthly cost. So here are your choices for the top part. The independent variable X represents the, and the dependent variable. So there's no way you can figure out the cost unless you know how many cups you bought. So the number of cups is the independent, and the dependent would be the total monthly cost. Because the price, the monthly cost, depends on that beautiful number of cups. Okay? What would be the function? So you have to pay 10 bucks in order to get this beautiful thing, and then $3 a cup after that. So we're going back to the good old y equals mx plus b, 3x plus 10. When you plug in 16, you're going to get $58. So that meaning that 16, I'm hoping, oh, there it is. 16 cups of coffee will cost $58. And then the other one says dollars monthly. I'm sorry that didn't crop up. That didn't do so well. Hopefully that's enough to make you more confident in trying this again. Let me know if there's any questions, and I hope you have a great day.